Welcome to chemistry classes on the topic chemical bonding. Today's class is class number 23 and it is the second class of chemical bonding, and it is a very important and common topic and very often question asked in the entrance and also in the class exam. And this topic is Lewis dot and formal charges. Lewis dot and formal charges based on octet rule. So these things, Lewis dot structures, you have already got it, but today we will just discuss regarding formal charge and what is the utility of the formal charges. So bit by bit you will go to the deep of the topic. So first of all let us tell some of the rules upon which we can write the Lewis dot structure. So this is the sum of the important facts you should know, and these things are very simple. You can very easily understand while I will draw the structures. First of all, count the total number of valence electrons in the molecules of the compound. The total valence electron of each atom should be counted first. Number two, place least electronegative element at the center, or the element which is less in number should be in the middle. Say it is H2O, less number is O should be in the middle. Say it is HClO4, less number element is Cl, so Cl should be in the middle. So H2SO4, less number of the atom is sulfur, sulfur should be in the middle. So less electronegative element or the less number of atom should be in the center, and then you place 2 electron each of the in between each of the atom. Then complete the octet of the outside atoms, and finally you complete the octet of the central atom. So first of all let me take a very simple one, methane. So you can very easily understand methane. So the carbon is in the middle, the total number of valence electron, carbon is, the valence electron is 4 and 4 hydrogen is 1, 4 hydrogen equal to 4, there is total 8 electron. So total valence electron is equal to 8 electron. Let us place 4 hydrogen in this way. Very simple, you might actually follow. And by the rule, place 2 electron in between each of the atom. So 2 electron in between. And see the total numbers of the electrons. So valence electrons have calculated at the very beginning is balanced or not. So there are 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Then the structure is this. The Lewis dot structure is this. Now, one point I have left. If the octet of center is missing, then arrange outside electron to complete the octet. Let me take one example you can understand very easily. Say NO3 negative. So first of all, total valence electron, nitrogen is equal to 5, hydrogen equal to 6, 6 to the 18, 18 plus 1 equal to 24, valence electron is NO3. So let us place the least number of element or atom, least number of atom is nitrogen in the middle, so N, and oxygen is in this way. So second point is over now, we should place 2 electron each in between each atom. 1, 2, 3. So let's see how many electrons in total is 24. So 1, 2, 3, 4, 5, 6. Now starts fulfilling the 8 electron by the side atom first. 2 is already here. 2, 2, 2, 2, 2, 2, 2, 2, 2. So let us count how many electrons? 8, 8, 8, 3 is the 24. That is, this is the Lewis dot structure. But it may not be a concrete and final structure. So let us check. Now, what is the criteria? See, what will be the exact probable structure, Lewis dot structures of NO3. So, by some way this is a structure, then we should consider the formal charge. What is formal charge? Formal charge is not accurate charge, not actual charge, that we depict it to explain whether which of these Lewis dot structure is suitable and good. I am explaining, just minutely follow. Now, what is formal charge? How to find out? That is valence electron minus number of lone pair electron minus number of bonds. This is the formula. Valence electron minus number of lone pair of electron, number of bonds. This is formal charge. We will check whether this structure is acceptable or there is better charge. Means, when we calculate the formal charges with the help of this formula, we will find some positive, negative, and 0. And then we will try to find out the net actual charges. Net means sum of all the charges. So, in this way we will judge. But maximum 0 structure with maximum 0 formal charge is the best structure. I am taking one example. Here, if you talk about this nitrogen and if you find out the formal charge of that nitrogen is equal to valence electron is equal to 5 minus how many lone pair? There is no lone pair. All are bond pair. So 1 bond, 2 bond, 3 bond. 5 minus 3 is equal to nitrogen, formal charge of nitrogen is equal to 3. Now come to this one, formal charge of this oxygen. These 3 oxygens are same. Let us find out only one oxygen. So for that oxygen, valence electron is equal to 6 minus lone pair. This is 1, 2, 3. 3 lone pair means 6 lone pair electron minus bond. How many bond? Only one bond with the nitrogen. So you are getting minus 1. So here minus 1, here minus 1, here minus 1. So you are getting, and all together minus 1, minus 1, minus 1. So this is one of the structure, maybe one of the structure. But let us see whether this structure is the exact structure or not. Now what I told, we have the options of moving the electron pair towards central atom to check whether there is maximum 0 formal charge. In place of formal charge, if maximum 0 appears by movement of the side by atoms electron towards the center, then that structure is appropriate. Now let us just shift this outside atoms one pair of electron here. So let's see what happens here. This remains same, but here for that oxygen, here 2 lone pair, one this pair and this pair here, and this pair has been arranged here. Earlier this was the pair of electron this, and in place we have placed this pair. So that is, the structure is actually this single bond O, double bond O, and here 1, 2, 3, 1, 2, 3, 1, 2, 3, and here only 2 pair. This is the structure. Am I right? Finally, we have arranged this lone pair of electron towards in between nitrogen and oxygen. So let's see what is the oxidation, what is the formal charge here? Valence electron of nitrogen minus lone pair, no lone pair, minus bond. How many bond? 1, 2, 3, 4. Here you are getting 4. That is, you are getting plus 1 here. Plus 1. And here in this case, you are getting, this is valence electron 6, lone pair total 6, 1 bond minus 1. So this is minus 1 and this is minus 1. And here this is 6 minus 1, 2, 3, 4. Lone pair is, number of electron is 4 and bond is 0. Here you are getting 0. Earlier we got this is plus 3 and minus 1, minus 1, minus 1. Now what we got here is here plus 1, minus 1, minus 1. But we have got 1, 0. So here also your total charge is minus 1, plus 1, minus 1 is 0, minus 1 is 1. Earlier case it is also minus 1, minus 1, minus 1, minus 3, it is 0. But here the formal charge appears here is 0. That is, the structure with more and more 0 formal charge is most reliable. Hence, this structure is the original structure, Lewis structures of NO3. Am I right? So this is one where we have seen that we have arranged some electron from the outermost atom in between center. Now one of the critical point just I am discussing, perchloric acid. Perchloric acid, valence electron 1, 7, 32 electron. Perchloric acid, less number, only 1, oxygen, 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 and here 1 hydrogen. So next we should place 2 electron in between any 2 atom, 2 electron. In place of 2 electron we can make a bond, so you can give 2 electron or in this way. I think it is simple. We can give 2 electrons, a lot of dots will be there, you may not understand, so you just give in this way. So yes, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we need 32, 10. Always 10. 11, 12, 13, 14, 16, 17, 18, 20, 21, 22, 24, 26, 28, 30, 32. 1, 2, 3, 4, 5, 6, 7, 8, 8, 8, 8, 34, 24, 26, 28, 30, 32. So we have arranged 32 electrons. Now whether this is the correct or original or the structures which can be good structure of Lewis, let us check. Find the formal charge of chlorine. Formal charge of chlorine equal to valence electron minus number of lone pair electron, no lone pair on chlorine, minus bond. How many bond? 1, 2, 3, 4. So you are getting plus 3. Minutely follow this one. So come to this one, 1 2 3 4. For that oxygen, that oxygen, that oxygen, you are getting valence electron 4, number of lone pair of electron 3 equal to 6, and minus bond, one bond is there, equal to minus 1. So you are getting minus 1, you are getting minus 1, you are getting minus 1. Come to this oxygen, here 6 minus valence electron is equal to 4, minus bond is equal to 2, here is equal to 0, you are getting 0. So in totality you are getting minus 1 minus 1 minus 1 plus 3. In totality it is 0. Am I right? That is 0, and this is only 1 0. Let us see whether there is any other possibility where we can make maximum 0 in this structure. This is the technique. This is the confusing things. You may not understand or you may not do these things, and you will get 0 in the exam. So you see this. This is the structure, and I have kept it plus 3 minus 1 minus 1 minus 1, and this is 0, and this is also 0. And let us just arrange. Let us just arrange. Let shift this here, shift this here, shift this here. Let's see what happens. What happens? Chlorine, we have shifted the lone pair towards the center from 3 oxygen, so 3 double bond. Let's see what's happened. Come to this oxygen formal charge. Formal charge 6 minus lone pair equal to 4 minus bond is equal to 2 equal to 0. So this is 0, this is 0. I am showing you that 0 in this way. This is 0, this is 0, this is 0, this is 0. And what is that chlorine? Chlorine equal to 7 minus no lone pair. How many bond? 2, 4, 6, 7. Again it is also 0. So the structure here we have just rearrange the electrons in such a way that maximum 0 formal charges appear, and this is the more and very good structure. So this is the main structure. So in exam what's happened, you are asked in perchloric acid, you are asked to find out the formal charge of this and this and this. Now I am taking one by one example, and you will find it very easily. You are asked find the formal charge of PO, P single bond O, means formal charge of O where P and O has single bond, it is told. You are asked to find out. Let us draw this P, 1 2 3 4. Am I right? How many electron? 5 and 6 4 ja 24 plus 3, again 32 electrons. So we have to place these 32 electrons in such a way around P, and so that the structure will be correct and feasible or very good structure. So first of all we will give 2 electrons each, means 1 bond. Am I right? So when we give 2 electrons means 2 2 2 2 means 8 electrons, and let us start satisfying the octet of each individual oxygen. Am I right? So 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6. Am I right? So you see 1 2 3 4 each is containing 8 electron. 4 8 ja 32 electron has been satisfied. Whether this is good structure? Certainly not. Let us take the help of the formal charge formula. What about the formal charge formula? And that oxygen in many times I have done it. This 6 number of electron is equal to 6, 1 bond is equal to -1, this is equal to -1. So this is -1, this is -1, this is -1, this is -1. Now what is phosphorus? Phosphorus is P, formal charge is this. There is no lone pair, but bond pair 1 2 3 4. So you are getting this equal to 1. So here you are getting 1. Let us check whether we can introduce more and more 0 in this structure, and the structure will be very good structure. So let's see. Let us arrange, first of all, let us arrange this lone pair here. So what's happened? See, double bond O, single bond O, single bond O, O. Am I right? 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4. Again you see we have got 18 electron, 32 electrons. So now come to this point. This is 0. This is -1. This is -1. This is -1. And if you think about this, then 5 minus number of lone pair is 0 minus bond 1 2 3 4 5 equal to 0. Here again you are getting 0. So in comparison to the earlier structure, we are getting more number of 0 in this structure. So minimum, if we can minimize the formal charge, the structure is very good structure. So your structure is this. So in the question, in the exam, in entrance exam, very often asked, you have to find out the formal charge of O, P single bond O. This is -1 -1 -1, and if it is P double bond O, O is the 0, and the central P is the 0. Again, let us see H2SO4. Hydrogen is 2, it is 6, it is 24, again it is 32. Total electron is 32. Valence electron 32. So least number is sulfur. Here there is oxygen is 4, 1, 2, 3, 4, and there is hydrogen. And by the rule we have told, we give just lone pair to 1, bond pair to each one. So how many electrons? 1 2 3 4 5 6 7 8 9 10. Now it's your turn to fill the individual side octet of the atom. So 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6 7 8. So you calculate, you are getting 32 electron. Now let us see calculate the formal charge of each and every one of atom. So the central sulfur, this is valence electron is equal to 6, number of lone pair is nil, bond 1 2 3 4 is equal to 4 is equal to 2. You are getting, for sulfur it is 2, for sulfur it is 2. For oxygen it is 0. You calculate yourself. For this oxygen, many times I have already done this one, and this is also -1. This is the structure. Now are there any possibility to minimize these formal charges? More the number of the zeros in the structure, more is the goods, more good is the structure. So let's see, 1 2 3 4, and this 1 2 3 4 1 2 3 4 5 6 1 2 3 4 5 6. Am I right? This is exactly the same as the earlier. So let us arrange this to here and this to here. Let's see the structure, what this structure becomes. The structure becomes as 1 2 3 4 5 6. Again you count this total number of electron is again 32. Now come to this formal charge is +2 -1 -1 -1 0. Am I right? So come to this one, it is 0. Come to this one, it is 0. Come to this one, it is minus. Come to this one, it is 0. Come to this 6 minus, no lone pair of electron, but bond is 2 2 4 5 6 6. Again it is 0. So in comparison these two structures, we have seen that in this structure maximum of the formal charge is 0. So we have minimized the formal charge. So this is the very good structure. Now in the exam it is asked, you are asked to find out the formal charge of O of SO bond in sulfuric acid. Answer -1. S double bond O is 0, S is 0, this is 0. Am I right? that is Lewis dot. What is drawback? Drawback. The drawback of the Lewis dot structure is that it cannot tell about the geometry of molecule. It cannot tell about the stability of the structures. It cannot tell about the energy of the structures. Am I right? This is all about formal search and Lewis dot structure. Hope you have find the class more interesting. In the next class, again I will take with the another exciting topics of chemical bonding. Thanks a lot for watching the class.